we get going?
No.
All right. Now I gotta find. Ooh, talk about good luck when I scroll. All right, so we left off on Monday with doing some math for replacement of people who have died. So the natural disasters have like a certain death toll, how long at a given rate. So kind of got some information up there. Does it take to replace those people that had died, population-wise? I'm not talking emotions here, okay? Computer charger? Yeah. You're welcome. Oh my god. All right. So I am gonna pull up. Hold on. Pulling my answers out.
Cheater.
I know. I'm such a cheater. I do all the work, and I know I shouldn't be a teacher. All right. Yeah. There it is. All right. So I'm pulling up my whiteboard. I almost expect to hear a groan when you see the template. Oh, come on. Zoom out.
What's that?
All right. So back in the beginning, in like Unit 0, we did dimensional analysis, or a fancy way of doing math, really, to really help with canceling and connecting units. And this is where I'll show you where I made my mistake, and luckily it wasn't too many of them, so I didn't have to I redid all of them anyways. All right, so I think last time we did dimensional analysis, I was doing it by hand, but like I said, I was with in Mr. T's classroom, so I didn't get a chance. What we've got to do, and I think it'll look familiar in a second. See if I can. Ooh, not that big. Is we've got to figure out people and time. So let me work through this first one for a second, and then I'll kind of go back and explain it. I don't care about inviting my coworkers. All right. There was 1,836 people that we needed to replace, right? That was for Hurricane Katrina, the very first one. We need to go from people and get it into time. How much time does it take to get that amount of people replaced? So our conversion was, back in the little paragraph above it, 229,000 people every day. So if you remember back when we were doing dimensional analysis, there is people and people on top and bottom, just kind of like a fraction, they cancel out. All right, now, let's see. We have, how many hours are in a day? 24. Versions, I guess. And in every 1 hour, not hours, we have 60. Because I've already done the math, so I already know how far I have to go in this equation. You might have to play around with it a little bit. So my days cancel out, my hours cancel out, and my people cancel out. So my answer is going to be in minutes. Now, if you remember the dimensional analysis, you multiply everything on the top, and you get a number. Multiply everything on the bottom, and you get a number. And then you divide, just like a normal fraction. So we'll see if I can draw it. I have no freaking idea. Ooh, can't remember. There. Yes, we did this last semester. So what is the 1836 times 24 times 60.
Wait, so how do we write this down in the box here?
You can just multiply all these together divided by these. That would work.
What I have here is 1836 divided by x equals 229,000 divided by 1 day.
You can do that if you want, or you can go with this, because I'm going to show you guys once we answer it where I made my mistake and why I'm drawing this out at this point, so I don't confuse myself again. KK in the packet, we're right where we left off. Number 14, past disasters. We're working on Hurricane Katrina. Calculator.
And that was 1 minute?
What was 1 minute?
You said the answer to this right here was 1 minute.
No, I didn't say the answer. I'm asking you guys to multiply all the top numbers. I haven't said anything about an answer.
Okay.
I heard what you said. I'm seeing if I get the same thing. Yep. Ooh. This is why I don't draw. Okay, we're going to go back to the... Let's see what other people get. Daryl and I got the same number. We're not using the same calculator, even though he's here. Yay, sophomores come back next week. Yeah. Mm-hmm. All right, good. KK got the right answer too. 2, 6. All right, on the bottom, this is a really easy multiplication. Is Leland, we got that by multiplying all the numbers on the top.
That's what I did. 1836 times 1 times 24 times 60.
Well, 3 people got the same answer I did, so I would just double check.
Okay.
Uh-huh. Nice. Yep, good. So when you get this, when you divide 2,643,840 by 229,000, like Daryl said, you get 11.54. I'm just going to stick with the 5. And we only have our minutes left. So it would take 11.5 minutes to replace all the people that died from Hurricane Katrina. KK, Leland asked the same question. Write whatever you need to remember how to do this. All right. So that is the answer for number 1. Where I screwed up and why I ended up writing it out this way and showing you guys this way. Hey, Gil, what's up? Your what?
My PE class is starting.
Oh, you got to talk to your counselor. Miss Braun. Okay?
It's in the office room.
The one up here, yeah, all the way at the end of the hallway. All right. So, what was I saying? Oh, so when I was doing my math super quick to try and give myself an answer key, I'd accidentally put the 60 minutes down here and the 1 hour up here. So that's why I ended up writing it out. And then I found where I made my mathematical error because my answer was not making sense. So basically what you have to do for the first 1, 2, hold on. The first 2, it's the same way. So instead of this one being here, you can put in the new number of, what is it? And then you're going to come up with something different. So go through this and figure out what it is. That can stay there. For number 2, which is the September 11th, 2001 attacks, where 2,996 people died. How long would it take to replace them?
Next.
Yes, same process. Everything's the same numbers except for that initial number. If you got 0.822 or whatever, yeah, I don't know how either. My guess is it's some sort of order of operations error. Good. Daryl got it. Maybe. Where's my mouse? There it is. What was your top number, Daryl? Do you remember? $241? No, 240. All right. So when you multiply these top 3 numbers, you should get 4,314,240. Okay. The 1 times 1 times this number gives you the 229,000. So when you take this 4 million number, divide it by 229,000, you should get about 18.8 minutes. It goes on beyond that, but I'm just using the first decimal. Leland, I feel like you hit the enter button twice. That's probably how you got that then. All right. So the next, what is it? So the next ones, if you go down to minutes, you're going to get big numbers. I'm going to tell you 3, 4 are in hours, so you can actually not do that part. So it's hours.
I don't even have that any, and I told you not.
Yeah. Yeah, if you went all the way to minutes, probably. I'm putting up here. The one that gets tricky is the months, and that one. Okay. So minutes, hours, and days can all be calculated in the same process. When you move to hours, you don't need that last part converting it to minutes. And when you move to days, you don't need this last conversion. All right, this can get deleted off and you're just working with this part. I'll help you out once you get to the month. So I want to give you guys a few minutes to work through everything but the last 3. If you can get to the last 3, that's fine. And then we'll go from there. Yeah. one might be wrong because I've got 13 hours on that one.
I thought it was
Miss
called
P?
the one
Yeah.
Okay, never mind. I was gonna ask you to move your cursor because that bar was in the way.
Oh. Hey.
You get the yak sale during in
Yeah.
class week, so tomorrow, clubs tomorrow. Also, I love your outfit.
Thank you. So KK, wherever I put, hold on, where's my mouse? So I put on here where you need to end. So you just did the most work for the minutes. Then I took off that last part of the dimensional analysis because it ends at hours. So people cancel out, days cancel out, you're left with hours. When you're doing days, you're going to take these two out. Okay, because you just want the people to cancel out and be left with the unit of days. So depending on which one you're working on, will tell you where you need to end. And I said I would help you with the months because that one, there's one little switch up with. So you don't have to do the 1 hour equals 60 minutes. In this case, in this scenario, yes, but it will not always be that way, Collationate. It's not always going to have just this and a bunch of ones on the bottom. In this case, it does, but for right now, it works. Come on, Daryl. What do you need? You're breaking everything.
Okay, so, what am I, okay, so to get hours,
Mm-hmm.
you said I'm leaving out 60 minutes.
Yep.
And,
So it becomes, what's the one you're working on? The 123? So it becomes the 123,700 times 24.
that's 2 months.
All right, and then divide that by 12.96. I just rounded it to 13. Leland, I don't even understand your question. There should not be scientific notation in this.
I'm doing the second hour, not second day.
The one that starts out with 225,000 people?
Yeah.
There still shouldn't be any scientific notation. You would take, stop it. There we go. What is it?
225,000 times 1 times 24. And that was all I did. I did that, and then I divided that by 229,000.
Okay. And what'd you get?
I haven't divided yet, but here I got 540. No wait, 5,400,000. I'm gonna divide that by 229,000, and it gives me 5,400 over 229. But if I convert that, it's scientific notation.
Are you converting to scientific notation? So it would be 23.6 hours, almost 24, almost 1 day. All right, good, KK. You're right on track for that. because I was doing it in a calculator, like where I could see my process, like the ones you use in math class. And so it would kind of show you as you were doing them. Because I didn't start out by doing it in the dimensional analysis format. I was doing the 225 divided by 229 times 24, and I was going back and forth with that. So I could see it as I was working where like a reasonable number.
I see what happened here.
Okay, good.
See what I did on my calculator. I have a shift function which converts it.
Yeah.
I was supposed to put it in twice.
Yeah. Mm-hmm. All right, so the first hour one, Daryl and I definitely did. We've got 12.96 hours. I just rounded it to 13. So I will do. I don't know if you guys. Has anyone gone to the days one yet?
I was about to, but I didn't get there.
All right. So Daryl, while you guys are working, Daryl asked a question of how did I know to do minutes, hours, days, or months? There's two things to that. One is I was doing some really funky math, and I was doing it with a graphing calculator, so I could kind of see as I was going where I was getting a reasonable number. Because I'll tell you, if I tried to do minutes for the Black Plague one, I would end up with a really big number, so I didn't want to go that far. I also realized that the approximate number of deaths are slowly increasing. So once I hit something like 23 hours, which is almost a full day, that my next one was probably going to be days. So it was kind of just some like thought process.
So you just cut off a whole section of math, went for hours, days, minutes.
Yep. Because I don't need to convert down to minutes and then try and convert it back to days to make the number make a little more sense. So if I told you, oh yeah, it took 3,742 minutes, that means nothing. It's a lot, but I don't really have a concept of what that is. So I'm putting it into like realistic numbers.
Okay.
Yep. Yep. Anyone get this one yet? The first. Oh, that's the second one. You did. Yeah, you did that one, Daryl. I was like, no, that's not what I got. I screwed up again, but this time it was you. Yep. Sort of. One little thing. All right. So what's going to change with the months part? We're going to have to make one slight change with months, converting to months. Anyone got guesses?
I was thinking maybe cut off another section, but I am not sure if that would work.
That would not work because then we'd just be left with the initial number.
Yeah.
This actually leads into KK's earlier question. Let me go back to. All right. Will we always just divide by that 229 in this case, or just that bottom number? No. So we've got to go from days to months. So for minutes, hours, and days, it was like breaking down. Now we need to kind of build up, really. So one day, we know that down here we have to have some sort of number of days, right?
Okay.
Do that. I'm going to do something a little shorter than that. And we want it in months. How many days are in a month?
It ranges from 20 to 31.
Average 30. Oh, let me take away the little bar. So this is when you actually have to multiply the numbers on the bottom. So the first one for months, the amount of people, 21 million. Right, so our top number actually stays the same because it's multiplied by 1 and by 1. And now what does our bottom number become?
Let's see. Let me write this down.
Is that it? This is what Daryl says it is. I didn't do the actual math in front of me. If you disagree with Daryl, let me know.
I got 6,870.
Okay.
I think Daryl put too many zeros. Oh, no, he put the right amount of zeros.
All right. So then what do you come up with? So pull out your calculator. I totally forgot I have these on the computer. And you have 21,000,023 divided by I have to count my zeros.
Okay. 3.05.
Yep. So it's just a little over 3 months. So I'll just put. All right. So you should be able to do the last two. Do those. Tell me what you get. I promise I did my math right this time. Yep. Yep. You're good. It's intimidating, but it's easy once you make stupid little mistakes like me, or don't make stupid little mistakes. Oops.
3.63 for the second one.
Yep. Oops, I typed the wrong number. No, just one. All right. Anyone other than Daryl get the Black Plague from 1347?
I'm doing that one right now. I got 10.91.
All right, good. All right. So you guys can learn from my mistake. I should have been doing the dimensional analysis from the start in order to get these numbers correct and keep my units in place. It wasn't until I did that I realized where I made the mistake in my math. And luckily it was only the first two I screwed up, so at least there's that. Any questions on this part? Because we are going to go back to our notes. Hey, JJ. All right. Take a screenshot, get those numbers down. I'm moving in 5 seconds. Oops, that's probably not helpful. There we go. And all I did was accidentally divide by 60 instead of multiply. All right, so back to your notes. We'll start right below and try and get through as much as we can. As far as class goes, I'm skipping over any of the articles or things like that, but I will tell you this is definitely a really interesting thing to read. Maybe, we'll see. So now I need to go back here. I need to figure out picture of M&M is. All right, back in your packets. Oh, I hate when it does this. There we go. All right, total fertility rate is the average number of children a woman produces in a population throughout her life. This is one of the things that you'll be looking at when you do your Unit 3 project, is looking at like how often women are reproducing in a country, since that is kind of part of their, you're fine, since that is part of kind of a symbol of success of a country, believe it or not. Women having babies. No, that's it is not Miley Cyrus. It's the oh my god, I can't remember what they're called, but KK, it's right below the table. What is it, the 17 and Me or whatever? The TV show. It was like a reality TV show. Some lady had a bunch of kids, and apparently that gets you a TV show.
Yeah, it's right below.
Okay, good. Table, right here.
The tiny table. Hey, what's up with that? On yours, the part that you have highlighted on your screen, that's below our mini table.
Oh, I don't know. It might just be weird word formatting. All right, moving on. Turn off your timer. Okay. So here's some total fertility rates, or TFR. You're going to often see it referred to throughout the world. The U.S. right now is at 1.8. I can't remember when we talked about replacement factor, but you have 2 parents that make only 1, potentially a half child. I don't know. That's not a good replacement rate. So that is one of the indications that the population is going to start shrinking. All right. In Africa, Nigeria, Africa, they have a TFR of 7.2, so that's a little over 7 kids on average per family. South Korea, they are at 1.1. The world average is 2.4. So this is a growing world population, but a shrinking kind of US and South Korea population.
So we're in the green.
No, right here.
Blue. That's, I don't know why I kept looking at South America.
No. All right. Oh, I did put it in there twice. That's why it's below your table. Okay. So I just copied and pasted too much when I did your packet. It's above and below the table, the total fertility rate. So world's smallest families, and you can kind of see fertility rates here off to the side. Egypt with a 3.3, India currently with 2.2, and this is over time, if I remember correctly. The replacement level right here is what I was just talking about. So any of the countries in this pink area right here, those are countries that are at least replacing their parents in population or more. All right, any of the ones outside are going to be not replacing that population, in an indication of a shrinking population. And when I say it's over time, this is a really strange graph. Your lines, blots, whatever they are time. So this would be 1950. This would be 2015. This would be 1950, 2015. So it's within those data points. It gives you kind of a time axis. No, this is just kind of a heads up. Replacement level fertility is what I was just talking about with that last graph. That is the total fertility rate required to offset an average number of deaths in a population to keep that population size stable. So this is our replacement level is 2, essentially 2.1 technically, because that's mom, that's dad. We're not talking clones or anything crazy, okay? Just normal, it takes 2 people to make a baby. The total fertility rate, in this case Japan, was at 3, and then it dipped below, and it's projected to keep going lower. All right, so they're not replacing their parents. Javea, its total fertility rate. I accidentally put it in there twice, so just kind of keep that in the back of your head. Yeah, I screwed up. So, where is it? So I put it, the total fertility rate, I put it above and below for some reason. And then this is your replacement one.
I don't have one on the top.
All right. So developed countries, the replacement level of about 2.0 due to high levels of industrialization and income. So it's kind of one of those things, they see a pattern of higher income families, which the US is considered in general, compared to some of the other countries we'll talk about in a second, and industrialization, so good workforce, all kind of give us a lower replacement or lower TFR, which gives us still a replacement level. However, Yeah, I accidentally put it in 2 places. No, you're not. Um, although we have the 1.8, which is close to 2. I think England is at 1.4 or 1.5, and they're much more fast in a population decline. So couple workforce and income and education actually all factor into low TFR. Developing countries need generally at least 2.2, and I know it's weird to think of 0.2 as a person, but keep in mind these are averages. No one's actually giving birth to 0.2 people. Or higher is necessary due to high levels of infant mortality. Oops, there you go. I'm actually going to switch back to the world map really quick. I'll come back to this. Okay, so when you see some of the higher TFRs, like we see in this red, orange, and purple area, those are countries that have high mortality rates for their children. Okay, Madagascar and all the other ones in here that I can't thoroughly see, not even with one eye closed. They have high mortality rates, so therefore they need to have more kids in order to still have a replacement level for their parents, population-wise. When we're looking at some of the more blue and green countries, for the most part, those are the more developed countries. They're going to have that lower TFR and a lower replacement rate because they have their children survive more often. All right. Developed countries is that one. And then developing countries is the 2.2. So 2.0, 2.2 averages out to 2.1. Am I good to move on?
Yeah.
All right. So like I said, I'm going to leave the article for you guys to do. It's not that difficult. It's not 400 questions like I usually put with it. And how China ended their one-child policy. There was a lot of bad things that happened during that policy. Family in 100 years. I am okay. I'm changing my mind here, so give me a second. I think so. I think I'm gonna have you guys. I mean, if you want to do it, I'll give extra credit for it or whatever. Skip over the family in 100 years, so predicting things about generations. It goes back to that initial population equation. I'll help you guys if you want to, but that will be like an office hours kind of thing. So do keep that in mind. In the essence of time, I'm going to have you guys skip that and the graphing. Is that the age gap? Yep. So everything, I'm going to pull up the notes so you guys can see. So everything from family in 100 years, the graphing here and analyzing it. I'm going to skip. I'll give extra credit for it. It is interesting, I think, but I want to get you guys through some of this. So, geography. Did I scroll too much? Nope, not enough. So come right down here to why do females have a greater life expectancy than males? And we're going to keep going with our notes there. If you have paper packet, it's on page 19, halfway down. I like doing that, but I don't have time right now. All right, so starting at why do females have a greater life expectancy than males, other than we're just smarter. Gender-specific diseases tend to hit males a lot harder. If you were in biology at all and you got to the point where you were doing gender-specific diseases, I think only Mr. Disney might have gotten that far last year. But because of the X and Y chromosomes, guys get really screwed over on a lot of those diseases, or even something as simple as being colorblind that is carried on those sex chromosomes. Hazardous lifestyle choices is found more often in men than women. Men were typically always the ones sent off to war, and they're typically the ones doing more dangerous jobs. They're typically, I mean, even now, typically on the oil rigs or coal mining or anything along those lines, you typically see more men doing them.
Where's this at?
What's that, Leland?
And so where's this at?
Right here. For me, it's on page 19. After these things.
Skipping a lot.
Yeah.
It's too far from what I went out there.
The problem is I can't find it.
Well, right now, we'll do it. Won't take it. What time are you usually done with school? About 1 o'clock?
Also, my argument for why guys can be more moral.
We got an M over there.
Just can't find it here.
It's 1 o'clock our time. Let's see.
All right.
Down there by 1:30.
All right. Ooh, there it is. So here's your world life expectancy map, just kind of in general. It says in your packet to list 3 countries with life expectancy over 75 years. So that would be the red countries. What are 3 countries that live? The US is one, Canada, Mexico. You could go into like Argentina, Australia, Norway, Sweden, basically all of the left half of Europe. I'm really curious. Oh, Japan is red. So any of those countries are life expectancy of 75 or more. What about 3 countries with under 50 years of life expectancy? I think that one's Kenya. Yeah, that would probably make sense. I'm really bad at my Africa countries, especially because they've changed since I've been in high school when I learned them. I can even pull up. All right, let's see. As you can see, most of the lower life expectancies are in the Africa region. There is this like one random one way up here, which is not, God, that is Saudi. That's one of the stands. Probably like Afghanistan or Iran. I can't remember what's right there. Which one is next to Nepal? My geography is failing me. Some of your worst ones, Angola is right over here. Tanzania. Dude, we're both wrong on Kenya. That's that one right there. That's where I was supposed to go in college, actually. So, this one is Angola. And then you have Mozambique and Tanzania. Nigeria are both right here. Mali. Those are all countries with below 50 years. So I would almost be dead. All right. So we've talked a little bit about this already, the infant and child mortality rates. This is just the blanks. I forgot to put the definitions in. These are the blanks in your packet. So infant mortality rate goes with number of deaths of children less than a year per 1,000 births. And child mortality rates, pretty much the same thing except for under 5 years of age. So it's still that rate of per 1,000 like we looked at with the crude birth rate, crude death rate. I have a hair in my mask and I'm getting really annoyed. We just differentiate between infant being under a year, child being up to 5 years. Niasia, right here. Infant mortality rate, child mortality rate. Okay. No, just the phrases. Okay. The next part, what are the factors of life expectancy, infant mortality rate, and child mortality rate in a country? Hold on, I'm just going to put them all up there. So you're looking at available health care and prenatal care, which we kind of talked about a little bit already, especially in some of the questions before in that article. Adequate food supply, so definitely need to be able to feed our babies. Potable drinking water. It's amazing how many countries still don't have access to drinkable water. They have to go through some work of like boiling and all that stuff, filtering it in order to drink it. Good sanitation. There's still some countries that go to the bathroom in their local creeks and rivers. Not a good use for a bidet. And then moderate to low levels of pollution. I feel like that's true with the exception of China being one of our biggest polluters. Good news, we'll be skipping a little bit more of our packet, even though I don't want to, but it is what it is. All right, I'm gonna move on. Maybe, there it goes. So right above the triangle and weird looking pyramids of this picture right here goes population pyramid. It sometimes does get referred to as an age gender pyramid because you've got ages on your y-axis, genders on your x. And basically, like we've kind of already talked about before, they display the number of individuals within that age group. So they kind of cohort them for each type of country. Oh, Germany's another one with zero growth. I forgot about that. We're heading to zero growth or negative growth. All right. The Power of the Pyramids project, I'm going to skip it. Again, I'll give extra credit if you guys want to do it. That's fine. You could. Only the So only the articles you need to do for homework, the Pyramid Project and the family went in 100 years project are extra credit. Okay. All right. So that should be the end of 2.4. Yep, because there's a lot tied to that Power of the Pyramid project. All right, so pull up 3.5 in your notes. You'll have to skip some space because that pyramid project's a little long. And there's like one article there with a couple questions.
All the way down to economic development, consumption, and sustainability.
Mm-hmm. And I'll try and cram some of this in the last 10 minutes. All right, so if you've taken AP Human Geo, which I have never actually asked you guys if you have, they have the same unit in there, except for it looks a little bit different. Instead of 4 stages of development, they look at 5. And that's also how I can tell when people just Google answers and get them wrong, because they always pull up AP Geo. But we're going to be looking at all of this and how it relates back to population. So development, consumption, and sustainability. This is kind of something I tend to live by. We don't need a handful of people doing zero waste perfectly. We need millions of people doing it very imperfect. That's what makes the biggest impact. No one likes you, go away.
That's okay. I'm used to it. That's why I don't ever go away.
Oh my God. All right. Better and not perfect. Does this imply to individual or systemic change? Both, neither. And everyone kind of has their own opinions on this. But what? Change. But we'll get into that probably a little bit later.
Bad enough.
Oh my God. I'm perfect. I know. Huh? Yeah. I'm going to skip this. All right. So theory of demographic transition. I'm skipping the video. Video counts as articles. But it's a short one, so you guys will be fine. Theory of demographic transition. So as a country moves from subsistence economy, which is just getting what it needs to survive, to industrialization and increased affluence, so more money, it undergoes a very predictable shift in population growth. And that's what demographic transition is all about. So how do those things define countries? Don't freak out just yet. Here's a picture of the demographic transition model. So stage 1 through 4 is what it was talking about, the predictable stages. When you have something stage 1, there's high birth rates, high death rates. That's these red and green lines up here. And pre-industrial, so that sustaining, just living to sustain and survive. Stage 2 is when they start to transition into a slightly more prosperous country. Your birth rate is still high, but your death rate starts to go down, and that's going to increase your population. Stage 3 is called the industrial stage, where your birth rates, this is where some of that education, industrialization, all that starts to come in. Women tend to have access to birth control, and you start seeing those birth rates drop. Your death rate is also dropped. So your population is increasing, but not as much as it does through the transitional stage. All right, and then post-industrial stage is stage 4. Those are where there are very low birth rates and very low death rates, and almost kind of like the predator-prey curve, at least that's what it reminds me of. You kind of see this little wobble, this little bounce back, like overshoot, die off, same kind of thing. And that's when you see it kind of reach its equilibrium. Oh, my packet fell apart. Oh, that's great. My stapler sucks. I would honestly just screenshot this into your note packet because I thought I put it in there, but I was going to end up having you draw it out and plot it. That's what the paste or type answer below here is for the demographic transition. I would just copy and paste this in here, and I won't make you do the graphing. All right, I'm going to move on. Here's just another version of it with a little bit more. KK, I said to copy and paste it underneath the demographic transition activity. I was going to have you guys draw it out and plot it, but yeah, just put it in there. And I'll save you the plotting time. I know. This is just, there you go, that one, KK. All right, this one is just a little bit more of a heavier data, I guess. And this also adds in the total population line. So you can see the super sharp increase there, and then it starts to level off once it gets really into stage 4. At this point in our world, almost nobody is down here. Very little, if they are, they're really close to the stage 2 line. I'm just going to keep going. Just another one, I like this because it correlates your population pyramids, with this is the one that has 5, with your 4 to 5 stages and what their population pyramids look like. Ours looks a little bit more like this, and we're going to end up, this would be your negative growth. So you're going down in population. Okay. I just put a bunch of examples up there. I'm not going to have you guys do the card sort. Hi? Nope. I'm skipping over the TED Talk, but please do it. It's, again, not that long. You're funny. Yeah, it's about condoms. The TED Talk is about condoms and how it made Thailand a better place. It's actually a really interesting video about their growth rates and stuff and how condoms made them a success. The iPad equation, this is one, if you ever get tested on it, it will kind of get given to you, but I doubt you'll ever actually have to do any math from it. It's more that you understand where it comes from and what is included in that impact. So it's used to simplify all the factors causing environmental degradation as far as human influence goes. I equals P times A times T, which is short for environmental impact is equal to the amount of population, the affluence, and the technology available. Okay, it's crucial to remember the three factors are intermediate causes, not root causes. So population alone is not going to only impact a certain way. Affluence alone is not going to affect the impact a certain way, and so on with the technology. Okay. Now, and speaking of condoms, since we've got 1 minute left, they've now had doctors come out saying you should wear 2 masks instead of 1. It doesn't work for condoms. It's not going to work for masks either. Just throwing that out there. If it doesn't seal, it doesn't seal. Putting 14 masks on is not going to work. Side note. I'm just going to give you guys the last couple slides because the bell is about to ring. Oh, there it is. I'll give it to you guys next time, but I am giving you guys a work time next period where I'll show a video kind of in the background for extra credit. Yes, KK, I could go back.
Okay.
So,
Bye, guys. Bye, everybody. See you on Monday.
yes, I'll see more people on Monday. It won't be just me and Daryl hanging out. Not that I don't enjoy your company. Really?
A couple of my kids.
Thank you, Ms. Peterson. Have a great day.
You too, KK.
Show up to your next class.